Hello Year 9s and welcome back to Mathemagic. In today's lesson we're moving on with our topic of linear relationships, and in particular we're looking at a concept called the gradient. So by the end of today's lesson we want to be able to explain what the gradient of a line is and also calculate the gradient for a linear relationship. Now, before we begin, let's do a quick recap of what we looked at in the last lesson. Now, in the last lesson, we talked about plotting vertical and horizontal lines on our Cartesian plane. And we noticed that if your line had an equation x is equal to 0, it made a vertical, x is equal to a number, so x is equal to a, for example, it made a vertical line like this. So here is my x is equal to a, and if we had y is equal to a number, so for example we said y is equal to b, that gave us a horizontal line like this. Let me try this again. And I can't draw horizontal lines, as it turns out. I should grab my ruler and help me out here. So y is equal to 0 gets me a horizontal line like this, and so this line here is y is equal to 0. Then on top of that, we also drew lines where the equation was y is equal to mx. And the thing that we noticed was that we put a dot at the origin, and then we substitute another value in particular, the one that we found the easiest was to substitute x is equal to 1 into the equation of our line. And it gave me another point that I could put on my Cartesian plane. And then I drew a straight line through those. And so these ones were the examples of y is equal to this is an example of y is equal to mx. And so that's the three special lines that we looked at last lesson, which only had one intercept. So each of these lines only had one intercept. So what we're going to be talking about today is we're talking about the gradient. Now, in particular, when you graphed those lines of y is equal to mx, we wanted to describe what was different about each one of them. And what made them different was that they had different angles or different slopes at which they were drawn. So that's what the gradient actually measures. So let's talk about the definition of the gradient. So here we have a definition. The gradient of a line is a measure of how steep or sloped the line is. So how steep the line is, so if it's going like this, or if it's going a lot steeper than that, or if it's going down this way, that is what the gradient measures. The gradient is a measure of how steep your line is. And so the way that we calculate this, we use the formula m. So m is just our notation here. So this m here is the way that mathematicians usually write gradient. We use m to represent it. Don't ask me why. We just decided that m was a nice letter. And so here the gradient is equal to rise over run. That's the formula we're going to be using. Now, rise over run is it's not very mathematical and numbery yet, but we're going to work towards that. So let's just have a look at the diagram to understand what rise over run is. Here, I've got a line, but I've only drawn a specific small section of this line. So I'm calling this is a line segment. And I've got my two endpoints on the left and on the right. What rise and run is basically going, okay, the rise is how many units do I need to go upwards to get from my first point to the second point. So here my rise is going to be this distance to get from the height of the lower point on the left, or the height of the point on the left, to the height on the point on my right. So this is my rise. The rise is how many units I need to go up or down by to go to my second point. And the run is how many horizontal units do I need to go from my first point to my second point. So here my run, maybe I should get my ruler out again to do this. My run is this distance here. From my first point to my second point, what is the horizontal distance here? So this is my run. Now, whenever we're doing this gradient thing, what I always recommend you do is to read these coordinates from left to right. So we're going to be starting on the point on the left, and then we're going to be going to the one on the right. So here, to get from this point on the left to the right, we have to go up by 2 units, and we need to go over 1, 2, 3, 4, 5, go across by 5 units. So my rise would be, for this example, so for this one, m would be equal to 2 over 5 for this example, because I have to go up by 2 units and then across by 5. Now, the reason why I say left to right is because sometimes you might be going downwards. And if it goes downwards, that means that the rise, instead of being a positive number, is going to be negative. So if my point instead was down here, that means that the rise would be a negative 2 units. So that's the formula we're going to be using. But as I said earlier, this is not very mathematical. And kind of like we rise over run, there's not very many numbers or algebra involved. So what we want to do is we want to create a rule that involves algebra for this equation of rise over run. And so the way we do this is we're going to introduce coordinates for our 2 points. So I'm going to say that this first point on the left, I'm going to call that my first coordinate. And the way I'm going to write this down is I'm going to say, okay, this one has the coordinates, and put a bracket here. This one has the coordinates x1, y1. Now the one at the bottom just indicates that this is my first coordinate. The one at the bottom just indicates that it's my first coordinate. So that's my x1, so the x coordinate of my first point. Y1 is y coordinate of my first point. And similarly, I'm going to call this second point up the top here x2, y2, because that is my second coordinate. So that x2, the small 2 just indicates that this is the x coordinate of my second point, and the y2 just indicates that it's my y coordinate of my second point. And now that I've introduced a few coordinates, we can actually figure out a rule that figures out rise over run. Now my rise is my vertical distance I'm going between the 2 points. And so here, my rise is going to involve my 2 y coordinates. So here, what I need to do to find my rise is I actually need to subtract the 2. And in particular, I'm going to go y2 minus y1. y2 minus y1. That's for my rise. So the rise here, I'm just going to, maybe I'll change it to match the colors to make it a little bit easier to see. My rise here is just y2 minus y1. Those are my 2 y coordinates. And my run is just going to be my x coordinates, and it's going to follow the same pattern. So here it's going to be x2 minus x1. And so here, this is the equation that we're going to use if we have coordinates to help me calculate my gradient. So that's what the gradient is. Let's actually have a go at a couple examples where we go and calculate the gradient. Now, actually, before we do that, sorry, my bad. Let me just talk about the different types of gradients. Now, this is this is just so that you can actually identify the shape of particular gradients. What will happen is your gradients are going to fall into one of 4 different categories. Now, the first one is if your line looks like this. So it goes from bottom left to top right. This type of gradient means that our graph or our line segment has a positive gradient. So this is a positive gradient. So if it starts in the bottom left and goes to the top right, it means it has a positive gradient. If it goes from top left to bottom right, so down this way, this is a negative gradient. So these are the first 2 types of gradients. And we can find numerical values for this, but this is just so you understand that all negative gradients will look like the green line, all positive gradients will look like the red line. And there's 2 more. If you have a horizontal line, so these were the lines where we said earlier was y is equal to a number. These have a gradient of 0. So if your line is flat, that means that the gradient is equal to 0. Now the other one is if your line is vertical. And if your line is vertical, that means that your gradient is undefined. Unfortunately, with this gradient formula, we have to go rise over run. If you have a look at this yellow line, there is no run, which means that the run would actually be 0. And in mathematics, we can't divide by 0, which is why the gradient, if you have a vertical line, is undefined. So these are the 4 types of gradients that you're going to notice with graphs. This is just generally like grouping our gradients, but usually what we want to do is actually find numerical values, particularly if you're in any of these first 2. You want to find a numerical value for your gradient. So actually, let's have a go at actually finding a few gradients using those rules, the rise over run formula that we had above. So example 1, identifying the type of gradient. So for each of the graphs, state whether or not the gradient is positive, negative, 0, or undefined. And if the gradient is positive or negative, we're going to find it. So let's have a go at this. So let's have a look at this first example here. If you just have a look at the shape of the line, so if you have a look at the direction it's going from bottom left to top right. bottom left to top right, which means that it has a positive gradient. So this one is going to be a positive gradient. Okay, now that we've done that, because it's a positive, we need to actually find what the gradient is. So I'm going to write here, the gradient formula is just rise over run. Okay, we're going to apply this formula, rise over run. We want to find a few points on our line, and then figure out how many units we have to go up by for our rise, and then figure out from there how many units we have to go left to right by for our run. So if you have a look here, there's actually a few easy points that I can notice. So first of all, I noticed that here they've even given us that we have this point over here at 2, 6. We have a point here at 2, 6. We've also been given that we have a point here, we have an x-intercept at 2, which means that we have another point at 0, 2. So what I'm going to do is I'm going to figure out the gradient based off of these 2 points. So let's first start off the rise. So here, the rise is how many vertical units we have to go up by. Now, if you have a look at the first point, we have a starting y coordinate of 2, and we have an ending on the second point, we have a y coordinate of 6. How many units do we go up by then? Well, if you have a look at those two values, 6 minus 2 gives me 4. So here, my rise is going to be 4. Okay, so that's all over the run, which is how many horizontal units I have to go by. Now, in the diagram, once again, the diagram's actually a little bit not to scale, but if you have a look at my x coordinates, well, the starting point has an x coordinate of 0, and my ending point has an x coordinate of 2, which means that I have to go across by 2 units. So for this one, the run is going to be 2. And so when I put that in, I get 4 divided by 2, which means that the gradient is 2. Okay, so that's how we use our rise over run formula. We want to figure out how many units we're going up or down by for my rise. And then from there, we want to figure out how many units we're going across by for my run. Okay, let's have a look at the next one, part B. Part B, if you have a look at this one, well, what type of shape does it have? We go from top left to bottom right for this one, which means that this is a negative gradient. Okay, so because it's a negative gradient, we actually need to go find it. So we're going to use our rise over run formula. So here I'm going to go m is equal to rise over run. Okay, let's start off with our rise. Now, remember, we're reading from left to right. So if you have a look at my diagram, I've kind of got 2 major pieces of information here. I've got my y-intercept, which means that I have a coordinate of 0, 3. And over here, I've got an x-intercept on the line, which means I have a coordinate of 2, 0. Okay, so let's have a look at the rise. Now the rise here, if you notice, we started at 3 and we go all the way down to 0. If you have a look, we're going downwards, which means that my rise is not going to just be 3, but instead, because we're going downwards, it's going to be minus 3. So here, this is my rise, and it's equal to minus 3. Okay? Then we're going to have a look for the run. The run is how many horizontal units I have to go across by. And here, I'm starting at 0, and I go to 2, which means I go across by 2 units. So here, this is going to be a run over a run of 2. Which gives you negative 3 over 2. Now, you could put this in a calculator and you would get negative 1.5. Or you can just leave it like this. Because this fraction can't be simplified any further, we can actually leave our gradient like this, negative 3 over 2. And that'd be fine. Okay, so that's how we can find our gradient for these 2 examples here. We want to just figure out how many vertical units we're going up or down by, which is my rise. And then we want to figure out how many horizontal units we're going by, which is my run. Making sure that we're going from left, making sure that we go from left to right. And then from there, we just divide those 2 values. Okay, let's have a look at the next 2 examples. Now, the next 2 examples, these 2 examples should be fairly quick. If you see a horizontal line just means that my gradient is equal to 0. If you have a horizontal line, we have a gradient of equal to 0. And my second one, if I've got a vertical line, that means that my gradient is undefined. We unfortunately do not have a value for this because we would divide by 0, which is a bit of a problem. Okay, so that's how we go about figuring out the gradient and identifying the shape of a gradient based off of the graph. Okay, now next part that we're going to have a look at is for this first 2 examples, we actually got given a graph to figure out the gradient from. And we could actually count up the units if we wanted to and figure out how many units we go up or down by and also how many units we go left or right by. sometimes they might just give you the coordinates. So they might just give you these coordinates and you have to find the gradient between those points. There's no dramas. We can still find the gradient of that. And here we're going to go through that. So I'm going to show you a few steps I want you guys to follow when we're doing this particular type of question. So here, this is calculating the gradient using the gradient formula that we had at the beginning. Now, when you're doing this, I've got a few steps I want to recommend you. The first one is label the first coordinate. So we're going to look at my two coordinates and pick one of them to be my first coordinate. And then we're going to say, okay, this is my first coordinate. And what we're going to do is we're going to label the coordinate, and in particular the x and y coordinates. And what we're going to do, we're going to call the x coordinate x1. This is the x coordinate of my first coordinate. I'm saying the word coordinate a lot, aren't I? Well, we're going to have to deal with it. And the second thing is I'm going to call my y coordinate of that point y1. So this is just labeling. This is the x coordinate of my first point, and this is the y coordinate of my first point. And then once we've done that, we're going to do the exact same thing, but for the second one. And instead of writing x1, we're going to write x2, because that's the x coordinate of my second point. And because we've done that for my x coordinate of my second point, I'm also going to do that for the y coordinate of the second point. So this is going to be y2. Okay, so we're going to label our 2 points, our 2 coordinates. Once we've done that, we're just going to substitute these values into this formula. So y2, I'm going to replace into here. y1, I'm going to replace into here. x2, I'm going to replace over here. And x1, I'm going to replace over here. So I'm just going to replace wherever I see those values into this formula. So I'm going to rewrite this formula a few times. And my general general kind of like trick for you guys is when you need to use a formula, write out the formula first as your first step. Write out the formula so that you know which parts to put it in and you don't make a mistake there. Okay. So substitute your values into the formula and then simplify in the end. So that's what we are going to do with the next couple of examples here. So we've got 2 examples here where we need to find the gradient between these points, and we're only given the coordinates. So find the gradient m of the line adjoining the given points. So let's have a look at this first one here. A. So in A, we've got our 2 points, A, 3, 4, and B, 5, 6. So the first thing that we did was we're going to label our 2 points. So what I said was, hopefully I move that down. Excellent. I'm going to call this first point A my first point, and I'm going to call B my second point. And so what I'm going to do is I'm going to label them. So I'm going to write up this. So here, 3, 4. So 3, that's the x coordinate of my first point. So I'm going to write here, 3 is going to be x1. Then 4 is going to be y1. Okay, so that's very straightforward. We're just labeling. Once we've done that, we're also going to do the same thing for my second one. So here, 5 is going to be x2 and 6 is going to be y2. So I've labeled all of my coordinates in my 2 points, in my 2 coordinates. Once I've done that, I'm just going to write out my formula. The gradient is equal to rise over run, but in this case, we're going to use that algebraic version that we developed at the beginning of this lesson. So here the formula is y2 minus y1 over x2 minus x1. So whenever you're substituting into a formula, I recommend as just the first step so you get this right is just write down the formula. Okay, now that I've done that, I'm just going to substitute values into this spot. So if you have a look at the top says y2 minus y1. So I'm going to find y2. Now, if you have a look at my labels, y2 is just the 6 at the end here. So I'm going to put this 6 here. 6 minus y1, which is at the start on the first coordinate, 4. And I'm going to divide that by x2. So at the bottom on my fraction, I've got x2 minus x1. So if you have a look up at the top, x2 is over here. So that is my 5. I'm going to have 5 minus x3, which is x1, which is 3 over here. I jumped a step. 3. So that's how we substitute these values in and also label it just to make sure that we've got the right thing. Okay. So 6, once we've done this, we're just going to simplify it. We're going to deal with the top part. 6 minus 4. 6 minus 4 is just going to be 2 over 5 minus 3, which is also 2. So that we've got 2 divided by 2. Now 2 divided by 2, it just gives me 1. Which means that my gradient of this line here is 1. It has a steepness of 1. Okay, so that's this first example here. The steps that we did, we want to label our first point, label our second point, substitute our values in, and then simplify. So those are the 4 steps we're going to follow. We're going to do those exact same 4 steps in my second question here. So this one here used to be B, but I moved it and now it's renamed itself. Let me just move this across. Okay. So this time we've got 2 new points. A is -3, 6, and B is 1, -3. Okay, we're going to follow the exact same steps. So I'm going to call A my first coordinate, and I'm going to call B my second coordinate. So let's label our points. -3 is going to be x1. It's the x coordinate of my first point. 6 is going to be y1. It's the y coordinate of my first point. 1 is going to be the x2 because it's the x coordinate of my second point. And -3 is going to be y2. It's y coordinate of my second point. Once we've done that, we can now put it into the formula. So I'm going to write out the formula. y2 minus y1 over x2 minus x1. And then once we've done this, all we need to do is start substituting the numbers in the right spots. So here, y2, that's the y coordinate on my second point, which is just at the top here, -3. So we're going to write -3. I should probably write an equal sign. -3 minus y1. y1 is my first y coordinate, which is just 6. So here, -6. And at the bottom, I've got x2, which is the x coordinate on my second point, which is 1, minus the y coordinate on my first point, which is -3. Now, because I'm doing minusing a negative number, I'm going to put a bracket around it just to make sure that we're keeping that number together. Okay, so let's have a look at the top part. -3 minus 6. Now, -3 minus 6 is going to give me -9. So -3 minus 6 gives me -9. So remember it from when we looked at operating with positive and negative numbers. When you have a number line, so I've got -3, and when I minus 6 from there, I'm going it back 6 more. So that gives me to -9. Okay, at the bottom, I've got 1 minus -3. When you've got minus a negative number, you're just going to plus it. So it's going to be 1 plus 3, which is 4. Now, if you have a look at this fraction, I can't simplify it any further. You could put it in your calculator, and this should give you -2.25, I believe. But we can actually just leave it like this, and this number should be fine. And so that's how we calculate the gradient using that gradient formula. 4 steps that we did. First step, we labeled our two coordinates. We've labeled it x1, y1 for our first one, and then x2, y. And then after that, we labeled our second coordinate. So we labeled it x2, y2. Then we substituted it into my formula. So I wrote out my formula just so I know where I'm putting in those numbers. And I just referred back to my labels and went, okay, this is what x2 is, this is what y2 is, this is what y1 is, this is what x2 is, this is what x1 is, and I put those values in. Then the final step is we simplify. We fixed up the top, we subtracted the numbers at the top, we subtracted the numbers at the bottom, and then if it's possible, we simplify. So that's how we find the gradient of between 2 points. Now, quick summary of today. In today's lesson, we talked about the gradient. The gradient is a measure of how steep or sloped a line is. And the way that we did this was we used a formula. The gradient, m, is equal to rise over run. So if we get given a diagram, all we need to do is just count how many units we're going up or down by and divide it by how many units we're going left to right by. And we also went through how to do this using algebra. And so what we had to do was use this formula. y2 minus y1 is equal to x2 minus x1. And what we wanted to do was we labeled the points, we substituted it in, and then we simplify. So that's how we go about finding the gradient. Hopefully that made sense. And if there's any questions, as always, you can send a comment or you can send me an email. But until next lesson, Year 9s, I hope you're staying safe wherever you are, and I will see you in our next video. Bye.